Okay, hello and welcome to my tutorial. This is a tutorial on beam design and how to design a beam on Excel. So it's a bit of coding involved. There are 5 steps and I'll try to keep it as concise and clear as possible. So this is the table that we're going to create first. And I will show you and talk you through step by step how to do it. And you will also need another tab over here called structural sections, and these are just generic sections with their dimensions and properties you can get off any website or the blue book, etc. If you're an engineering student or someone who spent time in the engineering field, you will know exactly what these are. Okay, so let's begin. So let's start from the beginning. So click on new, blank workspace, and let's save it before we do any work. So let's go to save as, beam design, and you want it to be saved as Excel macro enabled workbook, and we are going to call this beam design spreadsheet. And go save. Okay, so first things first, you want to create your table. So if we choose the cell B5 and begin to create our table, so first tab you want to write beam, then you want to put your beam reference, let's just call it B1 for now. Length, so obviously your beam will have a length, and we'll put meters for units, and we will leave a space for however many meters you want to put it. Let's just say for now 1.6 meters. Then reaction, design, so I will go on ahead and just fill in all the various headings that need to be put in. Okay, so now that I've gone on ahead and put in all the headings, so for example the span, the dead load, the live load, so that's the span on the left hand side, and then the span on the right hand side, because naturally if you had a beam you would have loading from the left hand side and the right hand side coming onto it, and then perhaps if it was a multi-story structure you would have loading from the walls above, etc. And then once the coding is done, you'll be able to see the UDL from these loadings, the point loads, the end reactions, because naturally if you have a beam and you have loading on it, there will be end reactions, and the moment. So I will just go ahead and make this a more obvious table. Okay, so just to highlight which cells that we will be putting values in or putting formulas into, I'm going to highlight and put them in a different color. So let's say, let's go for a green, make it a little bit lighter. There we go. Okay, so now we have our table, and now I'm going to put in some values. So let's say the left hand span is 3.3 meters. The dead load, let's just pluck a value out of thin air and say 4.52. 7.5. And for the time being, we'll say that there's no loading from the wall above, therefore we'll put 0, 0 in those two cells. And so once you have this set up, the next thing to add will be a cell here that says section, and momentarily we will put section satisfactory over here. Also, this value can be put in, it's a standard value of steel. I believe it's the stress value. Let me just center that. Also, just over here, create another little table. Okay, so at at M5 all the way to M8, stretch it to PQ, we want to create another table. So let's do this for now. And what we want to put up here in the second box down is XX, so that's the area of steel required in the X direction, Z, XX, and MCX, so that is the moment, the maximum moment that the section can tolerate. So the section is just going to go across here. This moment in time, I'm going to merge these three cells and put equals H12. So whatever is in H12, it will come back to being that box. At this moment in time, it's 0. These need to be centimeters to the 4. These are the units of IXX and ZXX, which is to the 3. And that, as everyone knows, moment is in kilonewton meters. UR stands for utilization ratio. So now that that is created, the next step is to put encoding in these cells here. So in C8, we are going to use this code. I've just created a little Word document. So this is all of these codings will go in each of these cells. So in C8, we're going to put that, and that just explains what this is. So this is all part of step 1 still. So in C8, as I already have this, I can just copy and paste, but obviously what you can do is just pause the video and then type it into your Excel spreadsheet. So I will do copy and paste, and as you can see, I have a value, so it's already picked it up. So what you can do is select the cell C8, click up here, and it will highlight all the cells that have been used in that formula. So we had the span C6 over here divided by 2 times by the dead load. So that gives you the UDL of the dead load, plus we go to G6, so that is the dead load but on the right hand side, times F6, which is the span on the right hand side, divided by 2. So then that's UDL on the right hand side plus I6, which is this value here, which we've put in 0 there because there's no loading from the wall above. Okay, so now we'll go ahead and put in the rest of the codes for the cell. So this is D8. So now that we have our UDL calculated with this code up here, as you can see, and the UDL for the dead, the live, the reactions for the dead and the live at both reactions A and B, etc. What I will do is just to make that easier to see. And because these have 4 decimal places after them, what we want to do is have it just set to 1. So I'm going to control select all of these, and right click, format cells, click on number and set it to 1 decimal place, and voila. Okay. Okay, so the next thing to do is to put the codes in to determine the moment, to determine the area of steel required when the deflection limit is the length over 360, and the area of steel required when the deflection limit is length over 200, and also the ZXX. Now, these are the formulas we need to use. So it says encoding for moment values and area of steel required in the table. So in cell C12, need to use this. What you can do is just pause the video at this moment and type in the codes. What I can do is just quickly copy and paste them in. So when I paste it in, it goes to 0, and there's a reason for this. It's because for step 2, we need to create the moment table, which is what we will get onto, but for this moment in time I'm just going to put the codes in, so the codes are still there. Right. Now for this one, cells J12 and K12 is will go into both, so I will have to merge the cells. So this moment in time it says fail, but that is mainly because it is related to the moment table that we do not have yet. So once that is created, it's related to the section table, which I spoke about earlier on in the video, and all you do is you create another tab and paste a generic section table in. I will do that as the video goes on. Okay, so now I am going to create the moment table. So what I'm going to do is begin at S4, which is just over here, to S10. So I will just do this just for reference. And at S4, I'm going to write distance. And leave a gap. So this, what I'm going to have here set up is the distance increments that are going to jump up in 0.01 for the moment. And the next thing to type is moment GQ dead UDL and the units kilonewton meter, moment QK live UDL kilonewton meter, then moment P1, which is point load, so the moment from the point load, and that will also be in kilonewton meter, moment from point load 2, and that is also kilonewton meter, the units. And then we're going to have a total moment kilonewton meter cell 2, right? I'm just going to stretch that there. And like I said before, I'm going to go up in increments of 0.01, and I'm going to do this all the way to 0.5, and this will give you complete accuracy of your total moment that is the result of the loads being applied to your structural member. Right, okay, so what I have done is I have gone on ahead and put in these distances at increments of 0.01 all the way to 0.5. I know it's a lot to do, but it's so worth it. So what I've gone ahead and done is all the way to there. So your last cell should be BR at 4, so BR4 at 0.5. And then for the rest of them, you don't need to put in the values because the coding will take care of it. So in here, once again, what I've done is I've just created a little a little Word spreadsheet with the various codings. So in cell T5, going to put this, and this is step 2, moment data table. So what you guys can do is just pause it and type it in. What I can do is just copy and paste T5. So this is T5 here, and I can go paste. And obviously this moment in time is going to be 0 because the value above that it's taking, T4, is 0. But once I've set in the code, they will all follow through. Right, next one. T6 is this. So I can go copy, paste, and finally T10. So this function is the sum of, so all the values from T6 to T9, it will add it up. That's what that function does. Paste. Okay, so now that all the formulas are set, all you have to do is select one of these and just drag it across literally all the way to the end. So just to BR, And that's one done. And these will all be 0 because if you look at the moment that's being calculated, it's being calculated from P1. And P1 at this moment in time, there are no values for P1. If, of course, you were to put values in, those would change. Okay, so now I'm going to make it look more like a table. And do this. You'll get some of these, it just means that your cell is not wide enough to show the values, so nothing to worry about, nothing wrong with the coding. It's just merely that the cell is telling you it needs more space. There we have it. Now, no one wants a beam spreadsheet with this and then all of this, so I have something up my sleeve. What you can do is select all of this right to the end, BR, and then right click and go to hide. So it's all still there between S and BS, but you can't see it, which makes it a lot more neater. So remember the values that didn't show up before? So this one here, C12, at the moment it was 0. Now, because we've gone ahead and created a moment table and set them to increments at 0. Going up in 0.01, now we have moments calculated here, which is great, and the ZXX section. What I'm going to do is set these to 1 decimal place, just to make it look neater. So now that is step 1 and step 2 complete. So now we are going to move on to step 3, which is importing or creating the structural section table. So you need to open up a new tab. I'm going to right click and rename this structural sections, and I'll go back to the original one with the coded beam design and rename it beam design. So back onto structural sections. So you can find the structural sections online. All you got to do is copy and paste it in. So I've done one previously, so all I'm going to do is just go to this table and copy and paste it. So by the structural sections table, I mean with the section designation, with the mass, the depth, the width, the web and flange thickness, etc. All of that information, root radius, elastic modulus, buckling parameters, etc. So all the way to area of section, and just copy all of them. So these are beams, and then I go into columns, any type of section that you want, basically, that you want to be an option in your design when you're designing. So I'm just going to go copy, open up the beam spreadsheet I've just been designing my beam design on. In cell B2, I'm going to paste. So now I have my structural sections. Okay, so the next thing to do, the next step, sorry, is step 4, and that is to create a drop-down tab in order for us to select the structural sections that we've just pasted into this page here. So what you've got to do is select the cell that you want, click on data, which is this tab up here. Click on data validation, and under settings, validation criteria, click list, because we want a list. Now under source, what I've gone ahead and done is just pasted the coding that you need, but structural sections comes from this tab here down there. So you need to put those in parentheses, which basically just means those these singular speech marks. So all you gotta do, all I gotta do is just copy and paste. Of course you've got to type it in and go paste, and then that is done. In input message, that should be ticked. Error alert, that should be ticked. And all you got to do is go to OK, and then when you come back you'll see the tab, and therefore you have all your sections that have been that you have pasted into your second sheet. So you can just select one, and as you may have noticed, as you put that code in, this one has come up here. So this one now matches this one up here, because this says these three boxes M and O equals H12, and H12 is this one over here. So that is step 4 complete. And so now we are on to step 5, and step 5 entails creating a cell that accommodates both text and formula. And so in order to do that, I'm just going to delete this here. Cells I12 and J12 I'm going to merge and center, and then put in this formula. So for step 5, for the text and formula into the same cell, I'm going to put this. So this is the if function. I will leave details down in the comment section, briefly explaining what the if function does, and also if I just quickly skip ahead and look at, if we look at cell N6, the VLOOKUP function, I will also briefly explain that. So going back to this one here, what it says, if you might have noticed, it says section adequate. That is what the text of the cell should read, but obviously it will be doing something else as well as just having text. It will be coding. So if I just copy that and paste into the cell that I've merged, I go paste, and at this moment in time it reads fail. Now the next thing to do is we're going to copy this in cell N6. So what you guys could do is just pause the video now and manually type in the codes in the various cells, N6, etc. So I will just copy and paste. So N6 is just over here, and if you can see, it's already formulated and it's worked out the area of steel required in the IXX direction. Paste, and so that is the moment that has been calculated. Now you might have noticed that this automatically appeared as section adequate. So what I can try and do is see if a smaller section, yep, is still within. So just to test it out, let's see. It works in the smallest section. Okay, great. Let's just set it to that one. So UR is utilization ratio. So what I'm going to do is put in a code to work out the ratio in terms of the steel provided and the steel required. So it will give you like a value at for example 0.5, and it will tell you that 50% of the utilization ratio has been it's used. If it's the closer it is to 1, that should be like a red sign saying you need to use a bigger section. Okay, so now I have my bending moment table where I can put in the span on the left hand side, the span on the right hand side, the dead and live loads, formula to calculate the UDL, dead and live, the reactions, the moment, the steel, area of steel required, and drop down list to pick various steel sections. And if it fails, it will come up as fail, but because this is well within, as in it passes in the moment resistance, and it passes in the area of steel required, therefore it says section adequate. We have our little design table here with the utilization ratios, and then this table here that's obviously hidden. So now we have our Excel beam design spreadsheet, and if say for example you have a multi-story structure and you need to design lots of beams, all you have to do is do this, copy and paste, and all you have to do is go in and change your parameters. So for example that will become B2 to represent beam 2, just enter that, and then let's say for example it's 3 meters in length, and on the left hand side it's supporting 4 meters, and on the right hand side it's supporting 2 meters, and the dead loads are now 3 kilonewtons per meter squared, and the live loads are 2 kilonewtons per meter, and it goes ahead and calculates. So for example if we look at these two here, so it's beam 1 and beam 2, so that UDL is 14.5 because obviously the parameters have changed, and this UDL is 9 and 6, so just to prove that it does work. Also the reactions are different, and the moment, and this is a good one because it shows you that this section fails, so therefore you have to increase your section, and therefore it becomes adequate, and you can check your utilization ratios, and there you have it. And you can copy and paste as many times as you want. You can add point loads, so for example if there was a point load of 1.5 dead and a point load of 3 live at say 0.5 meters spanning from the beam and this will take this into account, the end reactions will change, etc. Utilization ratio, everything will be factored in, and it's all done and dusted, and all you have to do is go ahead and copy and paste and then change the parameters and design your beams.